Okay, so the directions have 4 steps to them. First, we want to circle the hypothesis and underline the conclusion. Remember, the hypothesis is what follows the if, and the conclusion is what follows the then. Then we want to write the converse. The converse means to flip. Remember, you do a back flip in your Converse shoes. So instead of P then Q, the converse is Q then P. We want to determine if the converse is true or false, and then circle the appropriate answer. If false, we're going to give a counterexample. Remember, a counterexample proves the conditional is wrong. And then if both the conditional and the converse are true, we're going to write an if and only if biconditional, and we'll talk about biconditional in a moment. So for part 1, we're going to circle the hypothesis and underline the conclusion. The hypothesis is what follows the if before the then. So points being coplanar is my hypothesis. And we can call that P. Then they lie in the same plane. So let's underline the conclusion. They lie in the same plane. That's Q. Okay, the converse of that statement is to take our original Q and bring it to the front, and take our P and bring it to the back. So it should read if Q then P. So we want to say if Q, so if points lie in the same plane, then Q, or then P, which is the points are coplanar. So then they are coplanar. So we took our P and we brought it to the back. So points being coplanar is our P. We took our Q and we brought it to the front. Points lying in the same plane. So now it reads Q then P. Okay, so if points lie in the same plane, here's a bunch of points that lie in the same plane. They are coplanar. Well, that's true. There is no counterexample because that is a true statement. That's the definition of coplanar, points that lie in the same plane. So our if and only if statement. Our if and only if statement starts by saying the original hypothesis, points are coplanar, and then we put the words if and only if in between, and then your conclusion, they lie in the same plane. So an if and only if statement, we take our hypothesis P and we put an if and only if in between it and a Q. So we don't have the arrow here this time because the arrow implies if then. So we're not saying if P then Q, we're saying P if and only if Q. So points are coplanar if and only if they lie in the same plane. Alright, number 2, we just want to write the statement in if then form. So all children loving cartoons. You want to say something along the lines of if you are a child, or if someone is a child, or if there are children, then they love cartoons. You just have to make sure that your if-then statement makes sense. So go ahead and try number 3. Pause the video and see if you come up with something similar to what I come up with. So I had if a pair of angles is a linear pair, or are a linear pair, then they are supplementary. Alright, number 4, we want to identify if the following are converse, contrapositive, or inverse of the given statements. So remember, the converse is to take our original P then Q and take the flip of that, Q then P. Contrapositive is to negate the Q, negate the P. So we're flipping that conditional and then negating it. And the inverse is just to take the original hypothesis and negate it, and the original conclusion and negate it. So pause the video and see if you can figure out number 4. Okay, so the inverse of a statement is to negate it, and to negate means to take the opposite. So it says that if the mall is open. Well, here it says the mall is closed for our original hypothesis P. Well, the opposite of closed is open, so this is the opposite of P. I will spend my money at Walmart. Then here it says I will not spend my money at Walmart. That's the opposite of spending money. So that's the opposite of Q. That's our inverse. Letter B, if I don't spend my money at Walmart. Well, here it says I will spend my money at Walmart, and that was Q. Not spending your money at Walmart is the opposite of Q. then the mall is open. We said the mall was closed, and the mall being closed was P. The mall being opened is the opposite of P. So that's the flipping and negating of our original contrapositive. And letter C says, if I spend my money at Walmart, well, spending my money at Walmart was the conclusion, so it was Q. And the mall being closed was our hypothesis, so P. So we took our original P then Q and we flipped it so it read Q then P. That's our converse. Alright, and the last examples is using deductive laws, law of syllogism and law of detachment, to reach a conclusion. And the first one says to just translate the short argument into symbols and determine if the conclusion is valid. So we're looking for detachment or syllogism. So number 5, if two angles are adjacent and complementary, so adjacent and complementary is P, so this is P, then they form a right angle. So then they form a right angle, that's Q. If two angles form a right angle, well, here's two angles forming a right angle, so that's Q. Then their measures total 90. Well, we haven't talked about measures totaling 90 yet. So we're going to call that R. It's a whole new statement. And last it says, if two angles are adjacent and complementary, well, let's go back up here. It says two angles that are adjacent and complementary, that was P. Then their measures total 90. Their measures totaling 90 was referred to before, and that was R. So here we have P then Q, Q then R. The Q's are gone, so we conclude P then R. That is the law of syllogism. Alright, I'd like for you to pause the video and try number 6 on your own. So this one followed the law of detachment. Alright, number 7, saying if possible, write a conclusion. So writing a conclusion would be only if we have the law of detachment or the law of syllogism represented so that we could write a conclusion. So if a segment is bisected, that's P, then two congruent segments are formed, that's Q. If two segments are congruent, well, that's two congruent segments being formed, that's the same thing, two congruent segments, that's Q. Then they have the same measure. Well, we haven't talked about having the same measure yet, so we're going to call that R. So as you can see, we're following the law of syllogism. PQ, QR, Q's go away, we're left with P then R. So our conclusion is P then R. So if a segment is bisected, then they have the same measure. So we're going to say the two segments have the same measure because we need to refer to what they are. Otherwise, the sentence doesn't make sense. So they, being congruent segments, or the segments, have the same measure.